Algebra 1 8.4a, we're going to talk about how to solve word problems using either the substitution or addition method and how to know which one to use. For systems of equations, we look for two equations that'll give us one solution. And after we turn the words into a system of equations, we need to decide whether we're going to use substitution method or the addition method, and which is the best to find the solution. So here's our first word problem. Tala's soccer team has played 162 games and they've won 44 more games than they've lost. So how many did they lose? So let's pull the information out of this word problem. The total is 162 and the amount they've won is equal to the amount they lost plus 44. So let's set our variables for W for won and L for lost. That way we can keep track of it better than an X and a Y. So we've got the number that they won plus the number lost is 162. And we know that the number that they won minus how many they lost is equal to 44. See? So our two equations are W plus L for won plus lost. The total is 162. And the amount of games they won minus the losses of L is going to equal 44. So remember, there's an invisible 1 in front of these W's, and there's actually 1 in front of the L too. And we can see that the plus L and the minus L are zero pairs, aren't they? So that means we could use the addition method because we have a plus and a minus. That's going to create a zero pair. And remember that the 1 in front of that is going to make it a 2W, and 162 plus 44 is 206. Now we can just simplify it. We divide both sides of the equation by this coefficient 2. We get our buddy the invisible 1 identity property. So we have W is equal to 103. 206 divided by 2 is 103. Okay? So now we can plug this 103 in for the W in the first equation. W plus L is 162. We get 103 plus L is 162. And we can subtract 103 from each side, create a zero pair, and we get L is equal to 59. So we know that their wins are 103 and their losses are 59. See? If we add 59 and 44, we get 103, just like it said it would happen. See? All right, let's look at this one. Marcel sells cars and trucks and has 510 vehicles on his lot. He has 190 more cars than trucks. So how many trucks does he have? So we think the total is 510. And his trucks plus 190 is going to equal the cars because he has 190 more cars than trucks. So let's let C equal the cars and T equal the trucks, and then we can keep track of them. So the number of cars plus trucks is 510. That's our first equation. C plus T is 510. And the number of trucks plus 190 is going to equal the cars because he has 190 more. See? So T plus 190 is equal to C. So now we know that we can use substitution method and use T plus 190 in place of the C in this first equation. See? So we use the T plus 190 in place of C and substitute it in the first equation. So instead of C here, we have T plus 190 plus T. All right, so this is substitution method. And we can combine these two T's as like terms. So we got 2T plus 190 equals 510. We could subtract the 190 from each side of the equation to try to isolate this T. That creates a zero pair here, doesn't it? And now we've got 2T is equal to 320 because we subtract these and got 320. Now we can divide each side by this coefficient 2 to isolate that T. And identity property, we get our buddy the invisible 1, so we have a T is equal to 160. 320 divided by 2 is 160. Now we could go further if we wanted to. It only said to find out how many trucks he has, and we know they're 160. Well, we also know that if we add 190 to that, because T plus 190 is equal to the cars, so we could figure out how many cars he has. He has 350. And if we add the 350 and 160 together, it's going to equal 510, his original total. See? So it all works out really well, and we know we did it correctly. All right. Now, you're going to see a lot of problems like this about people with ages that are older or younger. So Tim is 21 years older than Emma. In 6 years, he'll be twice as old as Emma. So how old are they now? All right, so we can make a table to help us. See how I did that? So Tim is equal to 21 plus Emma, because his age is 21 more than Emma, all right? So T will be Tim, E will be Emma, And their age in 6 years is going to be a T plus 6, and she's going to be an E plus 6, right? So in 6 years, he's going to be twice as old as her. So Tim plus 6 is going to be 2 times Emma's age, all right, in the 6 years. So Tim's age now is 21 more than Emma's age now. So T equals 21 plus E. See? T equals 21 plus E. And in 6 years, Tim plus 6 years, he'll be twice Emma's age. So T plus 6, Tim in 6 years, is going to be equal to 2 times Emma plus the 6 years. See how we did that? So we got Emma plus the 6 years, just so we got Tim plus the 6 years, but it's going to be 2 times that. So we have to multiply her side by 2. Now we can simplify this and use distributive property, can't we? So we end up with 2e plus 12. Now we can subtract this 6 from each side to isolate that t. That creates a 0 pair. And on this side, we get 2e plus 6. Well, we could use the substitution method, and instead of using t, we'll use 2e plus 6 for the t, all right? So in this first equation, t equals 21 plus e, we're going to use 2e plus 6 equals 21 plus e, all right? That's what we got right here. So now we could subtract this 6 from each side to try to isolate this e, get that going. That creates a 0 pair. And now we've got 2e equals 15 plus e. Now I know you're thinking, well, which e do we isolate? Well, it would be better to subtract the e from this side, because then we'll end up with 1e on this side, wouldn't we? It'll be 1e, 2e minus an e is 1e, and we'll end up with the 15, so that's the quickest route to go. So we know Emma right now is 15 years old, okay? So that means if Emma's 15 and Tim is 21 years older than her, then Tim is 36 years old, see? Just remember to check it for mistakes. You want to make sure your math is correct, and you want to make sure your positive or negative signs are correct, all right? All right, here's our last one. Tomas rents a truck for 1 day for $33.95 plus 30 cents for every mile. Anna rents a truck for 1 day for $32.95, that's $1 less, and 32 cents per mile, that's 2 cents more. So at what mileage will their cost be the same? So we're going to let M be mileage and C be cost. Now because we want the cost to be the same, they can both equal C. So we've got $33.95 plus 30 cents times the mileage, because we don't know how many miles they're going to go. We're just going to use M for the mileage. And it's going to equal C. Then we've got $32.95 plus 32 cents times the mileage equals C. But we need to clear the decimals. So we've got 6 things here. 1, 2, 3, 4, 5, 6. And we're going to multiply every single one of them by 100 to clear the decimals. And it'll put that decimal point in the back of them, see? But it'll also make this 100C and that 100C. Well, they both have a plus sign. And we need to create a 0 pair. We need to start eliminating. So what we can do is multiply this second equation by -1. That'll help us create a 0 pair. Now, the second equation is negative 3295 minus 32m equals minus 100c. Now we can use the addition method, and we have a positive 100c and a negative 100c. That creates a 0 pair after the equal sign. Yeah, we could do that. So now we've got 100, after doing the subtraction, minus 2m equals 0. We need to isolate that m, don't we? That's the only variable that's there to isolate. So let's take away 100 from each side. That creates a 0 pair here. And we get negative 2m equals negative 100. Now we divide each side by this -2 coefficient. And that creates a positive 1. And negative 100 divided by -2 is a positive 50. So we know the mileage will be at 50 when the cost is the same. See? That's our answer. At what mileage will their cost be the same? At the 50th mile. See? Now we can solve for C by plugging M as 50, couldn't we? We can plug it into the original equation. All we have to do is multiply this 30 cents by 50 and get $15, and the cost will end up being $48.95. See? See how we did that? All right. The next video is going to be 8.4b. Sorry about the shadows. It's sunny and shadowy in here. And I'm going to do more systems of equations word problems because I know these can be really tricky. So if you want to see any of the previous few videos that I've made, those links are going to be in the description of this video, okay? And I'm going to put a link to my Grade 8 Math Systems of Equation playlist because that has a lot of the stuff that we're talking about, but the examples are different. So that might help you if you're stuck and you're still not quite getting it, or I'm going too fast. You can go look at that playlist, go through all the videos starting from the beginning, and between watching the ones from this series in Algebra 1 and that one, you should really know what you're doing, okay? And don't forget, you can make tables. Here's a table of this equation. We have Tomas at 30 cents, Anna at 32 cents. That's how much it's going to be charged for the miles, 30 cents per mile, 32 cents per mile, and then the daily rates, see? And that'll help you write the equation, okay? All right, so we're going to do another video on these word problems. I hope they're going to help you. Keep your chin up. We'll figure this out, all right? You'll be okay. All right, bye.